do, or in order to select that destination, you're going to use the general input. Input function, and this is just G input. And the thing in parentheses will tell it how many inputs you're going to enter. In this case, we're going to only enter one mouse click. So we're going to specify a single input. This is in the notes as well, so you don't need to take a picture of it. When you go through and use this general input, you have to assign it an X and Y, because it's going to return a vector quantity. It's going to return the X coordinate and the Y coordinate on the plot area, okay? If you click outside of the plot area, it'll pop up an error for you, okay? If you have your plot area viewable, but that there's nothing plotted at that point, what'll happen is MATLAB will automatically go in and assign the plot area. It'll go in and say, okay, well, we're on an interval from 0 to 1 on the x-axis, from 0 to 1 on the y-axis, and it'll just return the scale value on that interval, okay? So this is something that you would want to do after you have already assigned your plot area, your axis dimensions. That makes sense? So after you know the destination, then you're going to go through and determine if the destination is reachable. So let's say that we have, say, 20, 10. Is that reachable? Well, what would the reachable area be for this particular robot? So let's see, this first arm can reach 40, or first segment can reach 40 units, 30 units, 20 units, 10, and 5. That means that we have a total reachable space of, let's see, that's 70, 90, 105 units from the origin. Is this point within 105 units from the origin? Absolutely, so it is reachable, okay? So what we can do is just go through and calculate the distance from the origin to the destination and see if it's within the maximal reachable space that a robot can reach for. That makes sense. If it's not, you can just pop up some message saying, can't get there from here, and exit the loop. That makes sense. Finally, after you're all said and done, you're going to go through and show the motions that take place within your space, and then go through and record those locations in a matrix so that you can access them later on, okay? The reason for this is because the second part of this, assignment is going to have you take and plot the motion from your initial location to your destination with nice smooth motions on each joint. So if you have a initial angle here at 45 degrees and your final angle is 60 degrees, you're going to divide that up into an equal number of increments as your others so that you can show the motion from the first location to the second location. That kind of makes sense? This will be described a little more completely as we get further into the week. So what we're going to do tomorrow is go through and implement this on a two-axis, or I'm sorry, a two-joint robot, just so that you can see how we can develop this algorithm to do the work for us. Implementing it on a 5 or 6 joint robot isn't anything more complicated. It's just different numbers in our algorithm. Good? So, in order to demonstrate to you what the first part of your assignment should look like, then we have, so if you take a look here, as I mentioned, what I did was I went through and assigned my random angles here so that each time I run this, the robot's going to be in a different initial configuration. Next thing I did was I copied the initial parameters over into a destination parameter so that I had the same characteristics other than the angles. Okay, I wanted to have the same alpha angle and the same length and so on and so forth. I just didn't want to have to type them all over again. After I do that, I went through and used the same setup that we did before in order to perform all of our calculations. And right now you can see that it's sitting here not doing anything. When I mouse over the plot area, let me move this down, you can see that it's providing a crosshair for you to click on. Right there it'll record that position when you click, and that becomes your destination. Tomorrow, as we go through and start developing the algorithm itself, what we're going to do is go through, rotate that last joint so that it's pointing right over here, change our angle on our base joint so that we're sitting there, and then progressively go through the CCD algorithm in order to land at that destination. Good? Okay. So that's all I have for today. Are there any questions or comments on the homework? How do you guys do on it?
I had problems on the last one.
So just getting it to iterate through the loops.
Yeah.
So what I did there, let me go and kill this and